Hello everybody, welcome to this talk. Thank you for staying so long. I know it's been a busy, long day. What we're going to, the two Jameses are presenting today, so if in doubt, it's a James talking. We're going to hopefully talk and demonstrate OpenShift I/O, particularly focusing on continuous integration and continuous delivery. And I'm sure you've hopefully seen OpenShift I/O at the Keynote Summit, and hopefully you've been to some of the other talks. We're going to focus very much in the create stage here. So I'm not going to talk about stacks and analysis. I'm not going to talk about planning. We're going to stick purely in the create step. So let's try do a demo. And I'm going to try do a live demo. Let's see how it goes. So this is the OpenShift.io webpage when you get your account enabled. Go to the home page. I'll make this slightly bigger. And the font a little bit bigger. And I've already created a couple of spaces, which you can just see at the bottom. I'm going to go into the cheese space. And here's the space overview. And we're going to go straight into the add to space button. So I'm going to create a brand new app. We click this button. We get a nice little wizard up there. This lets us start off with a blank empty space. We can create brand new code from scratch. We can import existing code from an existing GitHub repository. In this case, we're going to create a brand new application. What's actually happening under the covers is we're using something called Jboss Forge, which is a wizardy thing for creating new applications. This Forge wizard has a whole bunch of pre-configured stacks, technology stacks, Spring Boot, Wildfly Swarm. In this case, let's stick with Vertex. And I'm going to give this a really imaginative title. Let's call it My Vertex 3, because that sounds pretty nice. If we click Next, what this is going to do under the covers is it's going to take that technology stack, create a brand new project and a Git repository, and it's also going to let us associate a pipeline with it. So pipelines are really how we move code from development to test to staging to run. Let me click Next. What we have is a pre-built set of pipelines for you to use. Not every developer understands how to create pipelines. We'll talk about how the pipelines work a little bit later. So we have a pre-canned set of 3 pipelines you can use. The first one just literally makes a release, and that's it. The second one creates a release and stages it. The third pipeline, which is the default that we're going to go with, is going to create the new release, it's going to stage it, then it's going to wait for human approval, and once human approval is received, it's going to then release to production. Oh, by the way, I should say, at any point in time, just put your hand up and ask a question. There's a lot to talk about today. Feel free to just jump in and shout and ask a question whenever we see anything. Right, so I'm going to click Finish. So under the covers now, if the demo gods are working, underneath the covers, we're going to create a brand new Git repository on GitHub. We're going to create an OpenShift build config, which is going to be the build that runs the pipeline. A Jenkins build is going to start, hopefully. And then we'll end up with a brand new pipeline, which should then start working. Yes, awesome, it worked. So that's good. That's a good start. That's a good start to the day. This could have been a really short demo if this bit didn't work. OK, so notice there's a Git URL. So if I just click on that link, this is GitHub's website, if you can't quite spot. So this is the new project we've just created in my personal user space. We can create projects in your own personal GitHub, or you can use GitHub organizations and create them there. Notice so there's a POM XML because this is a Vertex application. I'll show you the code later, don't worry about the code. Notice we've created the Jenkins file in there. So Jenkins file is a new thing in Jenkins 2, and a Jenkins file is a little bit like a make has a make file and rake has a rake file. Jenkins now has a Jenkins file with a capital J, and this is where you define the pipeline. If I quickly look at it, it's a Groovy file. Groovy is an excellent choice of language. They made a good choice there. Well played, those Jenkins guys. They know their stuff. So that's cool. What this pipeline's doing is the Maven node function is a way of defining a build pod that has Maven inside. I'll talk more about that a little bit later. And this is really just how the pipeline works. Inside the Maven container, the Docker container, all the build pipelines run inside containers. It's containers all the way down. We're going to make a new canary release. We're going to run an integration test. We're going to roll out to the staging environment. And then after human approval, we're going to go to production. So you can hack away at these Jenkins files all you like. What we found, though, is not many people yet know how to write pipelines. So we've got this nice pre-built library of pipelines, so you can just pick one and use it and get on with your job and make useful stuff. So if I click OK and close this window, and if I go into the Create tab and look at this Pipelines tab, we'll see, oh, I've got all sorts of stuff there that I didn't clear down in time. My vertex there. Oh, OK. I should have maybe cleaned up my stuff before I started the demo. Let me just delete some stuff. If you click on the View Log stuff, you get the Jenkins console opening. And if I just pop into Jenkins, I'm just going to close down a whole load of crap that I meant to delete. Let me just delete some of these bells. Bear with me. So this is the vanilla Jenkins console that you might know and love. There's also something called Blue Ocean in Jenkins now, which if I click on that, you get this new hipster console that looks all kind of shiny, which if I look at my Vertex 3 and this pipeline, we'll see the pipeline built here in Jenkins. So this is vanilla Jenkins. All we've really done is taken the upstream OpenShift Jenkins image, and we've just tweaked a couple of plugins, really, that's it. So it's vanilla Jenkins. If I go back to my console, my Vertex 3 should hopefully start building soon. Oops, wrong build. Bear with me a second. Okay, we'll come back to that later. I don't think there's any more builds running. Oh, sorry, yeah, let me kill that one. Because this is OpenShift, oh, there we go, that's helped. Thanks, James. Because this is the free version, we've kind of toned down the quotas, so everybody can only really run one Jenkins build at once. If you kind of pay some money or use this on a real OpenShift cluster, you can obviously run as many builds as you like. But the free version has kind of toned down how much quotas you get. I'll just leave that going for a little while. While that's going, let me show you a slightly different console. Here it is. This is another version of the console we're using. Let me just reload it. Oh, actually, let me hide the debugging I was doing earlier. This is another view. You notice that we now have an Applications tab here. The normal console doesn't have the Applications tab. This is a new screen we were working on last week that didn't quite make the code freeze for this Summit demo. So what we have is a pull request right now that adds this new tab, which shows all of our environments, and for each environment, which version of which application is running, and how many pods are running for each one. So from here, I can, for example, I can scale up this application and say, hey, let's run one pod there. It will then spin up one pod in the staging, and eventually that should go green. So we get a nice holistic view across all of our microservices and all of our environments of exactly how many pods are running in each one. And for things that are running, we can just click this link to test them out. So here I'm testing the staging version of this service, and I can say cheese. And, ooh, I get hello cheese. That's really awesome. So we get a single holistic view of all of our applications, exactly which version is running, how many pods are running, and there we go. We've now gone green. Because we've gone green, that means we're ready. So that means that pod is ready for traffic. So hopefully if I click on this, yay, it works. Awesome. If I say awesome, this new Vertex service is now working in that staging environment. Is my build working? Has it started yet? Oh, finally it started. OK. If I scroll down here, oh, the build pipeline's working. OK, cool. James, do you want to try your CI demo yet? Or you're not quite ready? OK, cool. We'll come on to that in a minute. Yeah, I'll tell you what, I'll do some slides describing how it all works, and then we'll go on to your demo. OK, so everything you've almost seen, once the pipeline builds, I'll show you it, is we're using Jenkins for continuous integration and continuous delivery. Continuous integration is really all about you're about to make a code change, and you want to test everything kind of works before you do a merge to master. And then continuous delivery is the process of when anything gets merged into master, you want to do a new versioned release. You want to release the jars and the POMs and the NPM packages and all that kind of stuff. You also want to make a version Docker image. And then you want to take that immutable binary Docker image and move it from testing to staging to production, right? So continuous integration is about testing your code changes before you release. And then continuous delivery is about moving that code automatically through all of your environments. And Fabricate, Freudian slip, OpenShift I/O automates all of this stuff, continuous integration and continuous delivery. The continuous integration and delivery is all using Jenkins pipelines. Let me just walk through how it kind of works under the covers. So I mentioned the Jenkins file before. I should go into present mode. Wait a second. Maybe I shouldn't have gone into present mode. Yeah, there we go. So there's a file called a Jenkins file that is a groovy DSL that defines all your different steps. We can extend the Jenkins file using something called pipeline libraries. In other words, you can import a library of functions that you can then use in your pipeline. So if you remember the Jenkins file I showed you before, the Maven node and the Maven release and the Maven integration tests, you can have a whole raft of different plugins or functions that make your pipeline nice and easy to write. One other thing we've done to help Jenkins work well with OpenShift is we have a Jenkins plugin called the Jenkins OpenShift Sync plugin. And what that does is synchronizes jobs and builds in Jenkins with OpenShift build configs and builds. So what that basically means is Jenkins jobs now look like native OpenShift builds. Whenever you create a build in Jenkins, it will trigger the build objects to be in OpenShift and vice versa. So you can use the OC command line in OpenShift to start builds, or you can use the OpenShift console to start builds, or the OpenShift I/O console to start builds, and vice versa, right? Which is kind of cool. We've also created 2 libraries to help you use Jenkins pipelines. So these are the things that are used under the covers in the wizard. But you can use these directly yourself if you're not using OpenShift I/O if you wish. The first is the pipeline library. So the pipeline library is a library of pipeline functions that let you do cool stuff. For example, we have a function that will do a Maven release. We have a function that will do a node release. We have functions that will submit pull requests and wait for them to be approved. We have functions that will wait for an artifact to be in, say, a Nexus repository. So we've got all these reusable functions that do useful stuff in the build pipeline that you can just call with one line of code in your Jenkins file. Then in addition, we have a Jenkins file library. In other words, a library of out-of-the-box Jenkins files that you can just use in your existing applications. So if you have a Node app or a .NET app or a Java app or whatever, we have a library of ready-to-reuse Jenkins files that you can just copy into your Git repository, commit it, and you've now got a really nice pipeline. So those are both really useful. So these are the 2 things that are used under the covers in that UI I just showed. Build pods. So everything we do is in a container. And so whenever we're running a continuous integration or a continuous delivery pipeline in Jenkins, what's actually happening under the covers is we're using a build pod to run the build. So this means we're reusing Kubernetes and OpenShift scalable container orchestration. If ever you've used Jenkins before in the past, you often have like a slave pool and things like that. What's kind of cool is when we're using Jenkins now, there is no slave pool. Whenever you create a build or trigger a build, it starts immediately, assuming you have enough resources on your OpenShift cluster, right? So we're using OpenShift pods to run each build, which is cool. This makes the build more repeatable because you know the exact versions of everything that's used in the build pod. Now, what you can use in your Jenkins file is you can describe exactly which version of all the images you wish to use. For example, if 2 different teams are using Maven, one team might want to use the latest, greatest Maven, another team might want to use an older version of Maven. If ever you've used Jenkins before, you often end up having a team of people who look after Jenkins for you, and you have to kind of raise tickets and say, please, can you install a new Maven for me so I can use it on my build? Now we let developers just define whatever tools they wish to use in their pipeline by using the Jenkins file, right? So you can use whatever tools you wish, whether it's Node or .NET or Swift or Go or whatever. You can define all of the tools you need in your pipeline using your Jenkins file. For example, you might want to use Selenium and certain browsers for doing integration testing and web-based testing and so forth. So the nice thing is if you put all this in your Jenkins file is in Git, so it's versioned. So any change to your pipeline or your software versions is then going through CI and CD, and you have an audit trail. I don't know if this has ever happened to you, but sometimes someone changes a job in Jenkins and it stops working, and no one has a clue why or who changed it and when and how to, more importantly, you don't know how to fix it to get it back. By putting everything in your Jenkins file, it means everything's in source code, so you can see when and why your pipeline changes, and then you can always roll back, right, if something bad happens. So those are build pods. Another thing about build pods, by the way, is you can mount secrets this way. Whenever you're doing continuous delivery particularly, you often need to deploy things somewhere. You need to push things to Docker registries. You need to do Git commits because you need to tag the source code and do a Git push. You probably need to go to, say, Artifactory or Nexus or whatever NPM package manager you use. So you're going to need to mount a bunch of secrets into your build pod so you can then do Git commits and pushes and whatnot. So using the same kind of build pods, we can mount secrets in the traditional Kubernetes way. So those are build pods. I just want to touch on branches, CI, and CD, right? So we check in this Jenkins file, which is cool. So that means we can then get CI and CD. What we kind of want to do is use one branch for CD. For example, let's say master. We might want to release from master, but have lots of different pull request branches or feature branches, where whenever I commit to those branches, I don't actually always want to do a real release, right? So you often want, say, master to be where releases come from, and then other branches, you want those to be, say, CI builds. You might have certain kind of branches that you say, well, whenever I commit in this branch, just build a snapshot image and run it somewhere, right? But don't do a real release. So we have different kinds of branches that do different kinds of things. So what we often have is different kinds of pipelines. We have CD pipelines where we're tagging Git with it. We're creating a new version. We're tagging Git with that version. We're making a real release and releasing it to, say, Maven Central or Nexus or Artifactory. We're creating a real version Docker image and pushing that to a registry and then staging it and whatnot. For CI builds, typically you may build a Docker image and whatnot, but it might just be a snapshot image. Or you might use a different naming convention. Oh, Christ. Note to self, terminate more apps before you present. And then developer builds, when you're a developer and you want builds to happen, you typically just want to run the app as quickly as possible so you can test changes. So we often have these kind of flavors of pipeline. And the way we configure this under the covers is we have something called a config map in your namespace that defines which branches are going to be CD, which branches are going to be CI, so that we know what flavor of pipeline to run based on which branch you're in. Doing it this way means we can set up conventions for people across many projects, and you don't have to kind of mess around with this stuff on a per app basis. For example, it saves every time you do a pull request, it saves messing with the Jenkins file in the pull request branch, right? Because master's going to have your CD pipeline in it. So doing it this way means you never have to touch the Jenkins file again once your Jenkins files are set up. And using this way, we can only do CD in a certain couple of branches. It might be that you want to do CD from a couple of branches because you might have, for example, you're releasing version 1 when there's a fix and you're releasing version 2 when there's a fix. So you might have a CD release in the version 1, a branch for version 1 and a branch for version 2, and each of them will do a release, but they'll be using different version ranges, right? The way we generate versions, by the way, is we use Git tags. So whenever you're in a branch with a Git tag, you tag the source code as, say, 2.3.4. Whenever the pipeline fires, it will look at the latest Git tag and increment that to make a new release. So if ever you want to automatically bump to a major version, you just do a Git tag, and the next release will use the new version. So we can support CD pipelines in multiple branches, releasing multiple version trees at the same time, which is kind of cool. All just using one setting in a config map. Was that all clear, right? Branches, CI, and CD. Cool. Environments. So all the demos you've seen today and the demo I almost did just now, we have multiple environments. Pretty much every developer I've ever talked to on a real system, we talk about environments. We say, oh, this is going to production now, this is going to staging, this is user acceptance test or whatever. The words we use for environments might be slightly different. Some people say UAT, some people say testing, some people say staging, some people say pre-prod or pre-production. But we're normally used to deploying to different environments. We usually deploy to testing first, then to maybe staging or pre-production, then to production. How environments work in OpenShift.io is we have another config map called Fabricate Environments, which this config map just defines what your environments are called, what order the deployments are done in, and where they are. Typically, these environments, all they literally are usually is OpenShift namespaces. So it allows you to have as many environments as you wish. It might be for your pipelines, you may want to have a SOAP testing environment, a user acceptance testing environment, a load testing environment, and you might want to run those in parallel, right? So you might have lots and lots of environments. You can configure these environments pretty trivially, but right now, unfortunately, it's a command line job. We will have a UI very soon to let you do that. So here's an example of my current config map for my environments. So you can see we've got 3 environments: test, stage, and run. The namespace entry is the actual physical OpenShift namespace where these things run. So if I go back to my console, how's that build going? Not great. Bear with me a second. Let me look at the build. Oh yeah. Let me check on the applications page. Yay, Vertex. Vertex 3 is starting. That's cool. So these environments test, stage, and run. These are the environments, and right now everything's in staging. And because my UI is not looking awesome, let me check. There's a bit of a bug. I'm going to approve through the Jenkins UI for now as a cheat. Let's proceed. Okay, I'm not going to do a promotion right now. There we go. So I'm rolling it. This is the Blue Ocean console in Jenkins. So you can see the stages in the pipeline. We have the build, the integration testing, the rollout, the approve, and so forth. If this is way too cool for you, you can always go back to the traditional Jenkins page and look at the same thing here, which is we're keeping it real. And yeah, there we go. So here's the traditional view, which some people prefer, which is fine. So there we go. Okay. So that's environments. Let me present. Any questions on anything about pipelines and CD? Yeah, go for it. You can use OpenShift's roles to make different users being able to edit or not resources. So you could say most developers don't have access to edit those. And you can pre-can those kind of things for people so that you can kind of lock it down for people breaking it. It's worth mentioning that even if you deleted everything from that file, the environments don't disappear. They just disappear from your pipelines and they disappear from the console. If ever you put it back again, it will then appear again in the UI. But yes, we probably want to make it read-only for most users, I think. Yeah. One thing I'll mention, by the way, this is a pipeline I was running earlier. We've added a little icon here that when you look at the pipeline screen, if ever you want to try out an application at one of the environments, we can just click here, and that will then open a new UI. So whenever we're deploying things to staging and testing and production, we've got nice little links that let you dive in quickly into there. Also, we can use this little kebab menu to start pipelines. So I can trigger a new pipeline here. So I could go here and start a pipeline there. Let's start that one. There we go. That's coming up there. That's looking a bit better. Also, we can look at the recent pipelines, so we can see all the history, or we usually can. I should maybe scale down some stuff, actually. I may be a bit, yeah. Let me just scale down some stuff, because I'm a bit out of quota. The out-of-the-box free tier with the quota is pretty much you can run a couple of apps for free before you start running out of quota. Oh, I'm running quite a lot. Okay, I'm going to scale some stuff down, which is probably why my demo wasn't working too well. Scale that one down. Let's see if that helps that one start. What we should see soon is the My Vertex 3 at the bottom. I've triggered that pipeline again, so once that pipeline gets going, we should hopefully see, you see these builders just starting. We can click on the view build logs to look at the log inside Jenkins if you really wish. And we can see it's chugging along. It's doing the Docker build at the minute. It's done the Maven. It's ran the unit tests. It's doing the build. Which version is it using? It's creating version 2.02, you can see, because it did 2.01 to start with. Now it's doing version 2.02. It's just uploaded the content into the local content repository. Now it's running, it's going to staging. If I click back here and look at the applications tab, I should see it in staging. You see 2.02 is now starting up in staging at the bottom there. So 2.02 is out. So production has, well, the run environment has 2.01. The staging environment will have 2.02 soon. It's just starting up right now. And then hopefully that goes green, and then we can approve it, and then it will hopefully go into production. There we go. So it's up. We can test it's working. I can click on this link. And yay, it's there. Awesome. Cool. Any other questions before I move on? Does that all make total sense? So we're using Jenkins files to do the build. Let me show you the Jenkins. Yeah, we're doing Jenkins files. Let me show you another thing. This project I created, there's a little link there, so we can just click on that link to go straight to the GitHub page. Here's the GitHub page. Let me show you how the pipeline library works. You see this first line of the Jenkins file? That's the kind of the magic stuff that says, please import the Fabricate pipeline library, so that all these functions we use, such as Maven node creates a Maven build pod, Maven Canary release does a Maven Canary release with a version you specify and so forth. Maven integration test runs integration tests in a separate namespace, so we're using the pre-built images, so you're testing the real Kubernetes manifests and the real Docker images there. All of these functions are defined in the library, so we just add this magic text at the top. If you have any Jenkins pipelines around and you want to try this right now, if you just add this library at the top, you can then reuse any of the libraries, any of the functions in our library, which is kind of cool. One other thing I just wanted to show you is, you see this console, you see the URL, you maybe can't quite read it. This is a kind of a slightly weird URL. This UI is a pull request build of a console. Let me show you the issue. So Fabricate runtime console, there we go. This GitHub project creates the pipeline page in the console, in the OpenShift IO console. So this builds an NPM module, which is cool and all. And if you look at the pull request, there's a pull request I created 5 days ago. So I created a pull request to add that new applications tab, which is cool. It unfortunately didn't make the release, which is a shame. But notice that there's these comments. Fabricate has commented on the pull request. So every time we make a pull request, Fabricate gets notified of the pull request. It then runs a CI build, which in this case creates a new Docker image for that pull request, and then stages it. And then it tells you where the app is running. So I can just click on that URL. That opens the new version of the console. I can then try it out and play with it and see if I like it or not. And then I can use that to help approve things. It's even more complicated than that, because this is a library which is then used by another project to build a real app. So it's taking the library and taking another project and building that project with this library and then deploying that to OpenShift and then commenting on the URL, right? But this automation is so awesome. I can't tell you how useful this is. Whenever you're changing consoles, you really want to get fast feedback. Particularly if some of your, say, junior developers have written a new page, the UX might look terrible. You kind of want to see what does it look like first before we approve it, right? Making good UIs is really, really hard, and you might want the UX folks to approve changes to see if they like it or not. So doing this kind of stuff, this kind of automation is amazing. I mean, we use this stuff all day long. If you've been in any of the other talks, you've maybe heard me say this before, but we use Fabricate to fabricate. So every piece of Fabricate, there's about 250 Git repos. Each one of those Git repos is versioned and released independently by Fabricate CI and CD. So every time we make a pull request, the CI is triggered automatically by Fabricate. It runs all of the CI tests. If the CI passes, it then comments on the GitHub issue. If it fails, it comments on the GitHub issue with a report and the log. Then when we do releases, every time we release any library, We release our new library to say Maven Central or NPM or whatever the project is. We have Docker, we have Node, we have Java, we have all kinds of crazy stuff. Each release then gets staged to wherever it needs to be, whether it's Docker Hub or whether it's Maven Central or whatever. Once the release is available and we've checked all of the public artifacts are there, the pipeline waits until they're all there. Sometimes Maven Central takes a little while to sync and so forth. Once everything's there, the pipelines then do pull requests against all the downstream projects. So whenever one of our core libraries change, we basically automatically generate in the pipelines pull requests on every other project that uses it. Submitting a pull request on the downstream projects then generates their CI builds, which then tests the new library in all the downstream projects. Then if those pull requests get merged, some of them have manual approval, some of them have automatic whatever, that then triggers the CD pipelines in the downstream projects. So we've basically automated everything, and it's amazing. And I think you all should do the same. That's a great question. I'll repeat it in case anybody didn't hear. It's basically what's the difference between OpenShift and OpenShift I/O, pretty much. So OpenShift I/O is a layer on top of OpenShift. It's using OpenShift. It's basically a UI and a set of services on top of OpenShift. OpenShift I/O is running on OpenShift. It's actually running on 2 OpenShift clusters. We have the shared services, which run on an OpenShift dedicated cluster. So things like the Planner and the Planner database, the Bayesian Analytics, the Fabricate Analytics, that's the old name. Fabricate Analytics, which does all the recommendations and checking for security vulnerabilities and all that kind of stuff, that's all shared services. We're using something called Keycloak for single sign-on. So the thing that's tracking your GitHub credential and your OpenShift Online credential and so forth, that's all running on OpenShift dedicated. Then the user, we call it the tenant services. The stuff a user has, like your own Jenkins, your own content repository and whatnot, that's running on OpenShift Online. So all the stuff I was doing with builds and deploys and everything, that's all OpenShift Online. If I go into here and I go into there, as soon as I'm looking at the pipelines view, this is talking directly to OpenShift Online, right? So this is OpenShift Online. This is just a different console talking to OpenShift Online. So if I open the OpenShift console, this is the regular OpenShift console of OpenShift Online. This is like vanilla OpenShift. There's this is just 100% vanilla OpenShift. We can see here's all the pipelines in OpenShift, right? So OpenShift I/O is OpenShift. It's just a bunch of extra stuff on top. So it's a developer-centric console. It's analytics. It's a planner. It's wizards for creating projects with pipelines, CI, CD, I've missed out some stuff, and Eclipse J, obviously Eclipse J as well. So it's basically a bunch of stuff on top of OpenShift. We love OpenShift, we think it's amazing. What OpenShift I/O is doing is trying to make an amazing developer experience on top of OpenShift, right? So I don't work in product management, so I can't possibly comment on a product. However, upstream, yes, all of this stuff works on every Kubernetes and OpenShift cluster. The thing I want more than anything else in the world on OpenShift I/O is to let you connect to other OpenShift clusters. So, because really under the covers, all this UI is just talking to an OpenShift REST endpoint with your credentials. It's using Keycloak to look up your key in OpenShift and then using the OpenShift REST API. So there is no reason why all this user experience can't work on Minishift, OpenShift dedicated, OpenShift container platform, any OpenShift, or even Kubernetes too. So at some point in the future, I am sure there will be something like this for any cluster, because upstream, it all works like that anyways. You can absolutely use Fabricate upstream right now, yes, on any platform. One of the things because we've been so busy with getting everything ready for Summit, we've slightly neglected upstream a little bit. As soon as the jet lag's gone next week, we're hacking the crap out of upstream to bring it back up into speed. Particularly because we haven't released the new console upstream, right? We decided to write all of the console in OpenShift.io using Angular 2. Well, you don't meant to mention 2 anymore. It's not Angular 1 anymore, Angular.js. So we've kind of got a really nice, shiny new console, which we haven't quite released upstream yet. So there will be an upstream version, yes. Yes. But also, I would imagine at some point we will work on premise anyways at OpenShift.io. But hassle Todd. Whenever you see Todd, hassle him and say, please, can I have the on-premise version like yesterday? Because I want that. That's a really good question. So let me step back slightly first. The CD and CI pipelines don't really care what tool you use, right? Right now we have CI and CD pipelines for Node, .NET, Ruby, Python, Go, Swift. I'm sure I've missed a few languages out there, right? So from a CI and CD pipeline, it really doesn't matter, right? We don't really care. What we've done with there's something called the Fabricate Maven plugin, which is awesome. And if you're using Maven and you want to use Kubernetes or OpenShift, definitely use the Fabricate Maven plugin. It's amazing. What it kind of does is it automates the generation of a Docker build for you, but it also generates something called a Kubernetes or OpenShift manifest. In other words, a blob of YAML or JSON. When you want to create things on OpenShift and Kubernetes, you need to kind of make this big blob of JSON or YAML where you define deployments and services and all these kind of stuff, right? What the Fabricate Maven plugin can do is detect your application, like is it Spring Boot, is it Wildfly Swarm, is it Vertex, is it, I don't know, Camel, whatever. Based on the tech stack, we then deduce what port it's going to listen to. For example, if it's a Spring Boot app, we'll detect the application.properties file, we'll detect which port your server's listing on, then we'll generate the right port mappings in your deployment YAML, right? So the Fabricate Maven plugin is awesome. You can take pretty much any Java app and just run it on Kubernetes automatically by just typing Maven Fabricate Run, and it just kind of works. It's amazing. If you're using Gradle, there's a shame because we don't have that awesomeness for Gradle yet. Someone in the community did do a Gradle plugin that when you run this Gradle plugin, it generates a POM from the Gradle dependencies so that we can use the Fabricate Maven plugin just to do the resource and deployment bits. I would prefer a better solution than that, but that works, right? That works fine. What would be nice is having a tool like that for any build environment, because making these Kubernetes and OpenShift manifests is kind of quite hard. It takes a lot of time. When we first started Fabricate, we used to do all this stuff by hand. We used to make these big manifests by hand, and the amount of times you'd make a mistake in a selector, for those who knows what this YAML looks like, and then everything would just break and you had no clue why. Now we just generate them all. Like I hardly ever have to look at the YAML because it just kind of generates it and works. The other thing that's really interesting is, what shall I show you? A deployment. Let me look at a deployment. If I go into, say, the stage environment, this is the OpenShift console now, but it will work in either console. If I look at the deployments, and I look at, say, my Vertex 3 that I just did, and I go into the edit YAML, okay, which is a pretty ninja thing. One thing I wanted to show you was every time we do a build and a release, let me make this a bit bigger. Everything we build in the pipelines, we annotate the crap out of it. So we have the git commit char, we have the branch that it was built from, we have where the metrics live in the console, we have the URL to the Git repository and so on and so forth. So we kind of know all of this metadata, and we can annotate all the deployments with this metadata. So when you're running something in production, you know where it was built, what's the issue tracker, what's the Git commit char and so forth. So we can kind of tie everything together to make it easy to tool the crap out of things. What we really want to do is if ever there's an exception in a log, we want to automatically create a new issue to describe which commit it was that broke the code to add the exception. Ideally, we'd like to assign the issue to the person who did the commit that made the mistake. We haven't quite got that piece yet, but if you want to help do that, that would be awesome. But that's where we really want to go, right? We're trying to tie everything end-to-end together so that we know every build, where it came from, what its version is, what its issue tracker is, who made it, where it came from. So when things go wrong, we can tie all that kind of stuff together. Did that answer your question? I've even forgotten what your question is. Yes, thanks. Any other questions about pipeline, CI, CD, or anything like that? One thing, let me just show you our current Jenkins we use internally to do all of our upstream open source releases, if this works. Yay, there we go. So this is our Jenkins that's running all of our CI and CD for all of our upstream projects. If I go into the Fabricate organization, these are all of the Git repositories in the Fabricate organization. We have lots of organizations, by the way. This is not it, but these are all the Git repositories that have a Jenkins file in them. There's a plugin in Jenkins called the Jenkins GitHub Organization Folder plugin. Is that the right name? I think. Which is really, really awesome, which lets you define a single Jenkins job that looks at a GitHub organization and periodically polls it to look at all of the repositories in that GitHub organization. And for each repository, what are all of the branches? And it looks in all the branches in all the Git repos in all the org to find out anything with a Jenkins file. And whenever it finds a Jenkins file, it makes a Jenkins job. So if any of our developers make a brand new Git repository in any of our organizations, we get an immediate CI and CD job created. And then whenever a pull request is made on one of those repos, we get the pull request CI integration, which then automatically comments on all the pull requests in GitHub, which is amazing. Right? This is how we do all of our releases, and it's all completely automated. So we never actually go in and create Jenkins jobs by hand or any of that kind of crap. It just automatically discovers all of our repositories.
So, sorry, I was just saying, I actually wanted to demonstrate this part of it, this CI part of it. Unfortunately, didn't quite get it in time. I'm a bit disappointed in myself, to be honest. But I just wanted really to highlight the importance of that, because what we found ourselves doing on the Fabricate project was automating lots of steps, and we're actually creating our CD pipelines. But over time now, we've actually been putting that automation and pushing it into CI. So we want to be having that faster feedback that James said, of having UI snapshot deployments, for example. All of this is actually in the OpenShift.io. Everything that we do now, we build upstream, and we will be, as we continue on our journey with OpenShift.io, you can actually you leverage this. So you can actually create, with that one click of a button, when you create your project, that generates all the webhooks and GitHub, and then triggers the GitHub organization plugin that does all the scanning. So you have all of this automation for free. This, I can't even begin where to explain how much pain this has saved us over the time. And also, I just want to really highlight that this is all part of the OpenShift.io solution that we're actually doing around CI/CD. And I just wanted to add that.
I mean, I remember when about 2 years ago, Fabricate started off as one Git repository. So it used to be a monolith. We'd release the whole thing from one Git repo. Then we started down our microservices journey, and we got to kind of about 8 repositories. And to do a release of just 8 projects used to take one person an entire day of just waiting for a release to be synced in Maven Central, sat there waiting. When it was there, quick curl, is it there? Yes. Okay, now do a pull request in the next project to use the new version, wait for it to release, and then the next one, and the next one, and the next one. It used to take a frustrating day of our lives just to do one release across 8 repos. Now we're releasing across 250 repositories because we've just automated everything, right? Which is amazing. What's interesting, the more automation you do, you suddenly start realizing how much manual crap we have to do, right? Like changing version numbers. We shouldn't ever have to manually change version numbers. If you were in the previous talk, the Fabricate Analytics talk in OpenShift.io, what we should be able to do really increasingly is automatically generate pull requests against your projects to use the correct versions of code that you should be using. Now, if you saw Todd's excellent keynote demo, which unfortunately was a video, but never mind, which scaredy cat. Yeah, actually mine didn't work at all. Ouch. Feel the burn. When you're in the Eclipse chair and you have the CVE, the security vulnerability, and it does the little red squiggly, that's really, really cool. What would be also cool, though, is to automatically generate pull requests if ever it detects a CV in your apps, so you don't have to open your editor to get that warning, right? We should be automatically generating pull requests. So we're Red Hat, and we have lots of supported open source libraries, right? Fuse, EAP, and all these other kind of libraries. Really what we should be doing with patches is we should be automating pull requests on your projects when a new patch is out with a security vulnerability that we think you should be using, right? So we should be able to analyze what code you're using and then generate pull requests against your code that then goes through your CI and your CD. And you can then approve those pull requests or reject them, it's up to you, so that then we automate migrating to new versions and patching code and whatnot. Okay, any other questions? Good call. Let me just find an example console. So we have a release.groovy in here. We have a little function here, if you can just see that does update downstream projects, where we can define all the projects to automate a pull request on. And we have one of these for Node and one of these for Java, where we can just list the repositories to do a pull request against. We also have another pipeline. So we have about kind of 60 quick starts, which are all in separate Git repositories, which is cool. But that's a nightmare to keep the versions in sync, right? If ever we release a new Fabricate Maven plugin, that's 60 pull requests to update all those kind of stuff, which is a nightmare. So we have another pipeline that all it does is iterate through every repository in an organization and update all of the versions to be in line with the central version POM XML. So we have another kind of pipeline that all it does is go through all of the projects and align all the versions if they're different, and does a pull request if they're different. A few people have asked about this. What we kind of would prefer to do is make that a reusable microservice so that anybody can have this capability on any project, right? What we kind of want to do is come up with a little magic file that we put into our Git repos that says, I want to subscribe to upstream versions, and using includes and excludes wildcards that says, you know, all my dependencies subscribe to, say, patch releases. Whenever there's a patch in any of my libraries, please update me. And then I have a separate microservice that goes through all your Git repositories and looks for this magic marker file and goes, they've subscribed to version upgrades, and then automatically generate the pull request. Because really, we shouldn't be doing this stuff by hand. I mean, it's insane. So we should be automating the crap out of all of this stuff, which would be really, really awesome. So hopefully we'll get that done later in the year. If you particularly want such a thing, then just work with us and we'll get it done quicker that way. But yes, we will get there eventually, though, as a community. Yeah. Any other questions? Right now, it only works with GitHub, yes. But we're hoping to support, there's something called GOGS, which is like an open source GitHub-like thing. There's something called GitLab as well. We're hoping to support, and then there's Atlassian and Stash. We'd kind of like to support all of the Git providers, really. The new Project Wizard supports GOGS right now. It doesn't support GitLab yet, but we'd like to get complete support for all the Git providers, really, because lots of people use different stuff. But both, yes. All this stuff is on the roadmap, absolutely. Like, what really excites us as a team is automating the crap out of stuff so developers get to go fast. So everything we've talked about today is absolutely on the roadmap. Well, everything you've seen right now is available in OpenShift.io, everything that worked anyways. And then all the other stuff will be coming soon, definitely, yes. I mean, right now we're using Fabricate pipelines to do all of the delivery of lots of the components in OpenShift.io. What I really want to be able to do is use OpenShift.io to watch OpenShift.io being developed, right? I want to be able to watch the real pipelines for implementing OpenShift.io, right, which we can't quite do right now because we don't support different clusters. But when we do support different clusters, that's going to be awesome. So then we could demonstrate doing real releases of OpenShift.io itself, which would be awesome. Any other questions? On anything at all? CI, CD, OpenShift.io, anything? Fabricate? Well, thank you very much. Thank you.